Hi student, welcome back to this video about factorization. In this video, I will talk about the basics of factorization, the concept, different methods, and we will do a few examples from easy to relatively advanced ones. So what is factorization? It's actually a mathematical process. Factorization is a mathematical process in which we try to break down a number or an expression into smaller building blocks of it. That if we multiply them back together, we will obtain the original expression. Okay, so it is called factorization because we are trying to pull out the common factor, right? So let me give you an example. So let's say we have 2y plus 6. Here, if you look closely, we could say that the 2 is a common factor, right? So I can pull it out. So if I pull out the 2 from the first one, what is left? Y. And from the second one, what is left? Number 3. This is a very simple example, okay? So uh, there are a few methods to do factorization. One of them, the most simple one, is called method of common factor. So method of common factor. This is the most simple one, right? And in this method, we take out the common factor amount among each term of the given expression. That's what I mean. Like this is a perfect example. So here we find the common factor, we pull it out. So let's do another example. So 4x plus 6. Again, the common factor that we want to pull out is 2. So that would be 2x plus 3. Okay, this is the most simple method. There is another method which is very similar to this one. Actually, the basic of this second method is the same as the first one. Here, we just have to do an extra step before factorizing, and it's called regrouping of terms. So regrouping of terms. Okay, so in this method, that means what I mean by regrouping, that means like we have to rearrange the given expression based on the like terms or similar terms. Okay, let me give you an example. So let's say I have 18x plus 33, okay, minus 6x squared minus 11x to the power 3. Okay, if you look at this expression closely, how many terms are there? 1, 2, 3, 4. Okay, 3 of the terms have got x, but this one is a constant. Okay, what I can do, I can just regroup them. What I mean, if I consider these two terms together, okay, and these two terms together, group them together, and do common factor, okay, let's see what happens. So consider the first two terms, 18x plus 33, and then factorize a 3, okay, so what is left? It's 6x plus 11, right? And then the third and the fourth term. Okay, let's see what we have here. So here, what I can do, sorry, it was 4. Okay, so here I can factorize minus x to the power 3, and let's see what is left here. If I factorize minus x to the power 3 from this term, let's see what is left. Okay, just to show you what I mean by pulling out a factor, that means division, right? It means dividing the original term by the common factor. Okay, because we want to have the original term if we multiply them back together. So let's see here. If I have negative 6x to the power 4, okay, and I divide it by negative x to the power 3, see what happens. The negative will cancel out with one another. And here I have 6 on its own. And then here I have x multiplied by itself 4 times. And here I have x multiplied by itself 3 times. So that would be x, x, x. And here x 1, 2, 3, 4. Okay, so 3 of these will be simplified with 3 of these. And what is left? Only 1x. And this is exactly what I put here. So 6x. So this one will jump here. Now for the next term, let's see. I'll do the next term here. So that would be negative 11x3. This is the original term. And this is the common factor that I'm going to pull out. So that would be negative x3. Okay, again, the two negative signs will cancel out. X cubed will cancel out. What is left? 11. Okay, so I just put it back here, 11, right? Okay, this is, so like if you see closely, now this looks very nice, but let's take a look at it again. So this term, like this parentheses and this parentheses are again similar, and it's repeating in both part of the expression, let's say. So what I can do again, I can just say, okay, now I will factorize this bracket. Okay, so what is left here? I would have number 3. And if I factorize this bracket, okay, what is left here? Negative x to the power 3. Okay, we will do more of these examples. Let's talk about the third method. The third method, I will just name it in this video, but we will discuss it in a like rather lengthy video. It's very important, and it's called factorization using identities. There are a few identities which are very famous in math, and you should be familiar with them. And you know, we use difference of squares or other methods to just factorize it. Okay, so as I just mentioned, factorization sometimes is very challenging, especially for complex expressions. However, if you do enough practice, it would be very easy. During the rest of the video, we will be doing some practice questions on factorization using the first and second method. Okay, let's continue. I've written some examples here for factorization. These are very basic, simple ones. When we are introduced to a new concept and we want to start practicing, we always start with the easiest ones, okay? So here we will be using the method of common factor. Take a look at the first example, 2x plus 4. What is the common factor here? If you take a look at it, like I could say 2 is a common factor, so I just pull it out. What is left? X plus 2. How about the second one? 5x minus 25. Okay, correct. 5 is a common factor. How can I find what is left? If I pull out the 5, let's see what is left. So the first term is 5x. I pull out the 5. Let's see what is left. X. How about the second term? Negative 25. I pull out the 5. What is left? Negative 5. Okay, so negative 5. Okay, how about the third one? Here, I would pull out the 3. Again, 3x divided by 3 is x. Negative 21 divided by 3 is negative 7. So that would be x minus 7. And doing number 4, I would say 3 again. So that would be 14x plus 5. Here, I would do 5. The first term, 5x squared divided by 5 would be x squared. Okay. And from the second term, 10 divided by 5 would be 2. As you can see, if you do multiplication on the second side of the equal sign, you will get exactly the same expression. So let's give it a try. 5 times x squared is 5x squared. 5 times 2, it's 10. Okay, let's do this one. For this one, I would say 7x. Okay, because both of them have got the term x. So let's do 21x squared divided by 7x. That would be 3x. Okay, and then what is left from the second one? Okay, let's do 14x divided by 7x. X will cancel out with this, 2, right? Okay, so these are some very simple ones. Let's do a few more. Now let's continue with more examples. Here we are moving from very simple ones to a little bit more difficult. Here, take a look at this one. I would say the common term sounds like 5x. So I will have 3 minus 5x. You can just pause the video, try to do all these example practice question on your own, and then check back your answer. Let's say for this one, again, the same thing. So 2 times x. 2 plus 3x is the answer. How about this one? This one, I'll go with 2x again, but take a look at here, 3x minus 2, right? In here, it's another type of question. The first term, you only have one variable, but with the second term, you have two variables. But the thing is, one of these variables is repeated in both terms. So what you can do, you can just factorize the term which is repeated in both terms. So let's say 2x. Then I'm left with x minus 2y. Okay. The same scenario in this one, there are two terms. The first term has got only t, the second term has got t and u as variable. But as you can see, the term t, the variable t is actually repeating in both terms. So what happens, I can factorize the 2t, which is the common term. Then I would have t plus 5u. The same thing applies to this one. Both of them have got the same two variables. So 3xy. Okay, this is the common term. Let's see what happens if I pull out the common term, which is 3xy. Okay, so 3 and 3 will cancel out. 1x will be cancelled out with this. One of the y will be cancelled out with this. So what is left? xy. Okay, and from the second term, okay, so let me write it here, 9xy divided by 3xy, this will cancel out with this. 9 divided by 3 would be 3. Okay, so the second term would be 3. You can just give it a try, multiply these two by one another, and you should see that the answer is exactly as this side. Okay, let's do another tree example, but this time we will try to solve these three from the second method, which is actually called the regrouping of terms. Let's see what I mean by regrouping. So here, I will consider these two because both of these, right, I can factorize a 3. And here I can factorize x3 from them. Okay, so let's see. At 3, that would be 6x plus 11. And here, if I factorize x3, that would be 6x plus 11, right? And here you can clearly see this parenthesis is repeated. So what I can do another factorization. So I would have 3 minus x3. Awesome. Next one. For the next one, let's take a look at closely. All of them have got variable x repeating. Okay, so one way would be factorizing an x, but a better solution would be considering these two together and then these two together, right? So let's see, 7x, and how do I know? It comes with practice. And these two terms, I will factorize x4, that would be 1 plus x2. Again, the same scenario. This is repeating itself. So I will factorize 1 plus x squared. So I would have 7x plus x4. Okay. Or you can go another step further. So if you take a look at here closely, you can factorize an x, right? So you could say, hey, I can do 1 plus x squared, factorize an x from here, and then 7 plus x to the power 3, right? And then this is the very last question for this video. It's one of my favorites. So here, you can see this pattern. It's kind of repeating. But here, the power is 2. What I can do here, I will factorize an x from the first one, right? And then I'm left with this thing. Then what I can do, I can factorize this part, which is repeating, exactly repeating. And then I'm left with this thing. And if you multiply these two, you will get exactly the same answer. I hope you enjoyed this video. If you have any more questions, please reach out to me. And I'll see you soon.